Let's solve the following linear inequality. This is a linear inequation because we have an inequality symbol involved here, and also linear because the highest power of x is 1. Let's begin. We have 3x minus 2 divided by 5, which is less than or equals to 4x minus 3 divided by 2. So we'll transpose 4x minus 3 over 2 from the right hand side to the left hand side to get 3x minus 2 divided by 5 minus 4x minus 3 divided by 2. This is going to be less than or equals to 0. We'll combine the two terms. In the denominator, the least common multiple of 5 and 2 will be 10. So in the numerator, we have 2 times 3x minus 2 minus 5 times 4x minus 3 less than or equals to 0. Now what we can do in the next step, we can multiply both sides of the equation with 10. So this is not going to affect the inequality symbol because 10 being a positive number. So here we can cancel out 10 and 10, and that leaves us with 0 on the right hand side. Now let's distribute 2 with 3x minus 2. So we have 6x minus 4 minus 5 times 4x will be 20x, and negative 5 times negative 3 will be 15. This is going to be less than or equals to 0. So 6x minus 20x, so that's negative 14x, and negative 4 plus 15, so this is positive 11. So this is less than or equals to 0. Let's transpose 11 from the left hand side to the right hand side. So this will give us negative 14x is less than or equals to negative 11. In the next step, what we'll do, we'll multiply both sides with negative 1. So that means we'll multiply negative 1 with 14x, and on the right hand side we'll multiply negative 1 to negative 11. In doing so, the sign of the inequality changes. So that means earlier it was less than or equal to, changes to greater than or equals to. So we have 14x greater than or equals to 11. Now we want to get rid of the coefficient of x, and we want to isolate x. So all we have to do is divide both sides with 14, and in doing so, the sign of the inequality is not going to flip or change because 14 is a positive number. So here we have x greater than or equals to 11 over 14. So this is the solution to our given linear inequality. And if we want to show the graphical way, this will be, we'll consider a real number line. On the real number line, we have the point 0 and 11 over 14. And here our values of x will be greater than or equals to 11 over 14. So that means our solution will lie to the right of 11 over 14. That means all the values greater than x, 11 over 14. And here 11 over 14 is also included, so we'll use a dot here. So this is the graphical way. And if we want to represent it in an interval form, so that will be, so our solution starts from 11 over 14 and goes all the way up to positive infinity, and this will be closed interval because 11 over 14 is included and infinity is unbounded, so we'll use an open interval here. So these are the ways of representing the solution to our given linear inequality.